Dear students, today we will be discussing about derivative of exponential and logarithmic function from the first principle or by the definition. We are continuing our lesson. First of all, exponential function. Exponential function that we have discussed e equal limit n tends to infinity 1 plus 1 by n to the power n, and also when n equal to 1 by h, so that s equal to 1 by n when n tends to infinity, s tends to 0 here. And so in this case e equal limit s tends to 0 1 plus s to the power 1 by h. In terms of x and y also we can discuss हैन, हामीले डिस्कस गरिरहेका छौं प्रिभियस लेसनमा. And the second part, dear students, this is the revision part that we have already studied. Properties of logarithmic functions. Number 1, log base a x dot y equal log ax plus log ay. Second property, log base ax by y equal log ax minus log ay. And similarly 3 number property, log base ax to the power n equal to n times log ax. Property number 4, log base a of a equal to 1. Property number 5, log am equal log ab times log bm. And 6 number, log a1 equal to. And then next part, dear students, few logarithmic functions and their relation. That can be used in this theorem. First principle that we have already studied, limit x tends to 0 log 1 plus x over x equal to 1. B number, limit x tends to 0 e to the power x minus 1 by x equal to 1. C number, limit x tends to 0 e to the power x minus 1 by x equal log a. This relation also we have discussed. And now Next part, dear students, which is very important part, expansion of e to the power x and log 1 plus x in infinite series. That in sequential series you can study more about this. Anyway, here just we will study about the pattern. Number 1, e to the power x equal to, we can write 1 plus x by 1 factorial. अब तिमीले factorial नबुझेको हुन सक्छौ, अहिले we will discuss later one. अहिले just pattern सम्झिने. 3 factorial plus we will be discussing for all values of x. यस्तो भने यो factorial हो, जस्तै 2 factorial भन्यो भने 2 times 1 हुन्छ, 3 factorials भन्यो भने 3 times 2 times 1 हुन्छ. Similarly go on. Number 2, log 1 plus x को ठाउँमा expanded form मा we can write x minus x square by 2 plus x cube by 3 minus ... up to infinity for -1 greater than x less or equal than 1. These are the some basic guidelines before starting the lesson of this logarithmic and exponential function from the first principle. Finding the derivative of number 1, find the derivative of log x, that is with base e, from the first principle. Solution. For this, dear students, let y equal to log x, del x add del y be the small increment in x and y respectively, then y plus del y equal x plus del x. Equation second minus first, then we get del y equal log x plus del x minus log x equal to as we have discussed, log a by b equal to log a minus log b. Using this property we can write this log x plus del x whole by x equal log x by x is 1 plus del x by x. Now dividing okay, so log a by b means log a minus log b. Instead of this we can write this, so log x plus del x minus log x is log x plus del x by x, like a by b. So separating these two terms, x by x gives 1 plus del x by x remains the same. Now dividing by del x on both side, del y by del x equal to log 1 plus del x by x whole over del x, and this, as we have studied, limit x tends to 0 log 1 plus x by x equal to 1. So del y by del x equal, we have to change this, log 1 plus del x by x, 1 plus x instead of x, here is del x by x. So del x by x we can make, we can divide by this, times x, it can be cancelled. 1 by x we can write later on. Now taking limits del x tends to 0 on both, limit del x tends to 0 del y by del x equal, limit del x tends to 0 log 1 plus del x by x over del x by x times 1 by x. By definition, dy by dx equal, this is 1 into 1 by x. Therefore derivative of log x equal to 1 by x. From the first principle, this is the final answer or the solution of this question. Now the second question, dear student, to find the derivative of e to the power x from first principle. Okay, solution for this question is, let y equal to e to the power x, let del x and del y be the small increment in x 1i respectively, then y plus del y equal e to the power x plus del x. Second equation, second minus first equation, del y equal e to the power x plus del x minus e to the power x. Then e to the power x times e to the power del x minus e to the power x, power plus भयो भने प्रोडक्टमा राख्छौं हामी, बेसको प्रोडक्टमा, and then e to the power x is common, e to the power del x minus 1, we can change in this format. Now dividing on both sides by del x, del y by del x equal e to the power x e del x minus 1 by del x, यति लैजान सक्छौं. Now taking limits as del x tends to 0 on both, limit del x tends to 0 del y by del x equal limit del x tends to 0 e to the power del x minus 1 by del x times e to the power x. We can change in this pattern. Okay, by definition, this is dy by dx equal note limit x tends to 0, e to the power x minus 1 by x equal to 1. The first part gives the same pattern, it is 1, and second is e to the power x. Therefore dy dx of e to the power x equal to e to the power x. This is the final answer. Next function, question number 3, dear students. 3 number question, find the derivative of e to the power x from the first principle. Solution: let y equal to a to the power x, let del x and del y be the small increment in x and y respectively. Then y plus del y equal e to the power x plus del x. This is second equation. Then second equation minus first equation, del y equal a to the power x plus del x minus a to the power x. Similarly, a to the power x is common, a to the power del x minus 1. Now dividing by del x, del y by del x equal a to the power x, a del x minus 1 by del x. Yes. Now taking limits is del x tends to 0, limit del x tends to 0, del y by del x equal limit del x tends to 0, a to the power del x minus 1 by del x times a to the power x. And we know limit x tends to 0, a to the power x minus 1 by x equal to a log a. So by definition, dy by dx equal, this is log a into a to the power not is a to the power x itself, a to the power x. del x को पो 0 छ, a to the power x केही गर्न पाइएन. Therefore dy by dx of a to the power x भनेको चाहिँ a to the power x भनेको चाहिँ फाइनल्ली के आयो त भन्दा a to the power x नै आयो र log a आयो. यो चाहिँ डेरिभेटिभ अफ यति फाइनल्ली आन्सर आयो. Number 4, dear students, find the derivative of log base ax with respect to x by definition, where x is greater than 0, a is also greater than 0, and a does not equal to 1. This is the property of logarithmic function.
So with respect to
x. Solution, dear students. Let y equal to log base ax. First equation. Let del x and del y be the small increment in x and y respectively, then y plus del y equal log base a x plus del x. Second equation. Second equation minus first, del y equal log base a x plus del x minus log base a x equal same base, log a x plus del x by x equal log base a 1 plus del x by x. Sorry. Now dividing on both by del x, del y by del x equal log base a 1 plus del x by x whole by del x. Then taking limits as del x tends to 0, limit del x tends to 0, del y over del x equal limit del x tends to 0 log base a 1 plus del x by x whole over x. Note log base ax equal to log base ex times log ea. We can break in this way, log ex into log instead of this we can write like this way. It will be easier to remember. Log ax equal log ex log ea. Yeah, and now in this step, limit del x tends to 0, we have given हैन हामीलाई के दिएछ भन्दा y equal to log ax भन्ने दिएछ. Let del x and del y be the small increment in x and y respectively गर्यौं. Then y plus del y equal to log ax plus del x भइहाल्यो. Del y equal to second minus first गर्दा log ax plus del x minus log ax भइहाल्यो. Log a भनेको x plus del x by x भइहाल्यो. यो x लाई सेपरेट गर्दा 1 plus del x by x log a base a को रूपमा यो भइहाल्यो. अब हामीलाई थाहा छ, we know that हैन, हामी स्टडी गरिरा छौं. तपाईको log ax लाई ब्रेक गर्दा log ae times log ax यो बेस लाई चेन्ज गर्छौं लोगारिथमिक प्रपर्टी अनुसार. त्यही भएर यसलाई पनि हामी त्यही रूपमा एक्सप्रेस गर्नको लागि यो नोट याद गर्नु पर्यो. नाउ डिवाइडिङ अन बोथ साइड बाइ del x, यहाँ पनि del x ले डिवाइड गरियो. लिमिट पनि del x टेन्ड्स टु 0 लियो. यो पार्ट सम्म केही नयाँ भएन. त्यसपछि तपाईहरुको यहाँनेर अब log ax भनेको log ex log ae हो. अब log ex e यो x यो होल लाई x को रूपमा log ex by del x times log ae यो log ae यसलाई यता राख्यो. अनि लिमिट्स del x टेन्ड्स टु log e 1 plus del x by x into 1 by x यो प्याटर्नमा लग्यो. हामी log 1 by हामीले फेरि अर्को के पढेछौँ, लिमिट डेल एक्स टेन्स टु 0 लग 1 प्लस एक्स बाई एक्स इक्वल टु 1 पढेका छौँ हामीले होइन। त्यही भएर यसलाई पनि यो लग भनेको बेस ई हो, त्यही भएर यो लग ई भनेको नि बेस ईको रूपमा लिएको भयो। सो लग ई 1 प्लस डेल एक्स बाई एक्स ओभर डेल एक्स बाई एक्स टाइम्स 1 बाई एक्स। यो त एक्सलाई कट गर्नको लागि यो डेल एक्सलाई एक्सको फर्ममा डेल एक्स बाई एक्स बनाइयो, अनि यो पार्ट हाम्रो लग एई चाहिँ यत्तिकै बाँकी रह्यो। अनि त्यसपछि नयाँ स्टेपमा बाई द डेफिनेसन हामी के गर्यौँ, डिवाई बाई डिएक्स इक्वल टु यो सबैले 1 दियो, 1 बाई एक्स इट्सेल्फ 1 बाई एक्स भयो, अनि लग एई नै रह्यो। देयरफोर द डेरिभेटिभ अफ लग एक्स चाहिँ के भयो, लग एई ओभर एक्स 1 बाई एक्स लग एई, यो पार्टमा हाम्रो डेरिभेटिभ फाइन्डिङ भयो। नाउ विल बी डिस्कसिङ द सिमिलर प्याटर्न क्वेसन होइन। सपोज द क्वेसन विल बी लाइक दिस।
Sir,